All right, y'all, we're going to finish up section 4.2 today, talking about experimental design. We talked about experiments last time, and we're going to build on that. To start out on the first part here, it says watch a video, and it's not linked here on your paper, but I did go ahead and put that link in Canvas. So what I'm going to have you do is go to Canvas to watch that video, and you're going to use that video to answer some of these questions. You'll need to use a little bit of the knowledge that you learned last time, and you're going to answer questions 1 through 4. Okay, once you've finished with question 4, you'll come back to the video so we can talk about those items before moving on to the rest of the activity for today. All right, in the video, they had marketed club soda as a way to get stronger. Okay, they changed the label, and based on that and all of the amping up that went into the marketing, we had someone who actually showed physically stronger results on that machine. They were able to hit the bell on the second time after drinking the club soda. So this notion is called the placebo effect, and you've probably heard that word before. Okay, placebo is an inactive treatment. And sometimes we have an inactive treatment have real-life results, and that's the placebo effect. Okay, basically, sometimes if you think something's going to make something happen, in this case, they think that the drink is going to make them stronger, then sometimes it does. Okay, and so that's not necessarily because of the drink, but because of other factors or confounding variables. Okay, the next thing you were asked to do was talk about this experiment that was done on caffeine and to identify some of the problems with it. Okay, remember when we were talking about an experiment, you have to have two different groups. You have to have somebody who has the treatment and then some part without the treatment. So there's nothing to compare the results to. Something like you didn't split it into groups. We need to make sure that you know that when we're building an experiment, we have to have a control group or a group that does not have a treatment. Okay, so make sure that you have some part indicating that. And then caffeine may not be the only thing that affects heart rate. A sugar could increase pulse rate, not the caffeine. So we're going to watch for any other variables. You may have listed some other options that talked about heart rate, maybe what their starting heart rate was, maybe if they were, sitting, standing, things like that. Okay, so we're going to control for other variables if we can. And then something that's really important that's kind of new here is we haven't talked about when we are doing separate groups, the ability to mask whether the group has the treatment or not. So when we talked about this last time with the ACT prep course, there's no way to mask that. If you went to the ACT prep course, you know that you were taking the ACT prep course. But in this case, we could make it where we take off the labels or cover up the labels for the caffeinated soda and the non-caffeinated soda. We could think about that so they don't know if they're drinking caffeine or not. And that's really part of the how we fix some of these issues are these things. Okay, so that was your question number 3. But I want you to add this part because this is new. We weren't able to do this last time. When we are able to conceal the treatments, that's considered blinding. Okay, on number 4, you were asked to actually design the experiment. Okay, hopefully you remember this setup from last time. We start with so many students. We randomly assign them into 2 groups. We want to make sure that they're roughly equivalent. In the case of this, they had 32 students, just some random class size, because I don't believe they told you what the class size was. Nope. So you could have chosen any appropriate number for a class size there, no problem. And then you split it into 2 roughly equal groups. Treatment 1 would be soda with caffeine. And then treatment 2 was soda without caffeine. That's going to help us see if the caffeine was the cause of the increased heart rate, or maybe another thing was playing into that, like the sugar. Okay, both of these would have sugar in them, and so we'll be able to determine more clearly whether that was the effect. Okay, so our caffeine here, free, would be our control group. That's our baseline when caffeine isn't added. So what I want you to make sure you add here is that this part is our control group, and you may have had that up top as well. And then this one we talked about last time, this is a completely randomized design. And now we're going to talk about things that aren't completely randomized. Instead, they're broken down even further into more groups. Okay, so what I want you to do, and this first one, is a completely randomized design. Okay, so why this is different than last time is because you are picking the treatments. Okay, versus last time I gave you what the treatment was supposed to be, ACT score or not, so we're practicing with that. And maybe on the last one you weren't sure how to apply the treatments. Maybe your control group here, instead of having caffeine and caffeine free, was no soda and soda. Problem with that is we're not able to decide if sugar is actually the cause here. Okay, so that's why a caffeinated and a non-caffeinated was a little bit better. But it is different. There are different ways to set up an experiment. Our goal is to practice so that we can get more confident on the best way to set it up for whatever we're trying to measure. Okay, so I want you to read through this, and I only want you to complete number 1 because we're going to do number 2 together where we break it down a little bit further. Okay, so pause the video and try number 1 for me. Okay, you should have had something. This one, it did tell you how many students, so we have 50 students, and we're going to randomly assign them to the online prep course or the teacher prep course with 25 in each group. This is one, just as a reminder, where blinding wouldn't be possible because people are going to know whether they're taking the prep course online or not online. Okay, so that's not something that's possible. Okay, the one before, blinding was possible because we had the idea that one was caffeinated and one was not. We can hide that. Okay. And we're going to talk about 2 types of blinding, going from one direction or the other. While we couldn't blind whether the students themselves knew whether they were in the prep course that was online or the teacher, we could blind the results and not let the analyst know which results came from which. Okay, so we'll talk about that when we get to some definitions here. All right, let's look at this one together. It says, the counselors at Hayes High hypothesized that online versus classroom results could be greatly affected by the grade level of students. So we're going to take this another notch, and we're going to try to help break it down by grade level of student as well. It says, they know that seniors generally score better on the ACT than juniors. How could we adjust our experiment to ensure that there is an even split of juniors and seniors in each class? Draw an outline of the experiment with your modifications. Okay, so I'm going to backtrack to what our original one looked like, and we'll have to talk about the changes that we need to make based on what we know. Okay, so we still have 50 students, but there are 20 seniors and there are 30 juniors. And so we're going to have to do something a little bit different before we get to this stage of where we assign them to our different groups of online prep and teacher prep. We're still going to have these 2 separate groups, but we're going to have them within what's called a block for the 20 seniors, and then within another block, which is called, another block, which is the 30 juniors. Okay, so let's go ahead and set that up. Sorry about that. We're going to start with our 50 students still. You'll want to, we're going to have to design 2 different branches here, so you'll want to write small enough so all of this fits. Okay, so we're starting with our 50 students still. Okay, but then we're going to split them into the 2 groups, and I'm going to go back and look at those numbers. First one was 20 seniors and then 30 juniors. Juniors. And now from here, a lot of the next steps are going to look very similar. Within each of these groups, we're designing a random assignment to our different treatments that we have. Okay, so we still want to randomly assign. Okay, group 1, group 2. And in this case, group 1 would have 10 seniors. And then group 2 would have 10 as well, because we always want these to be roughly equivalent. And then we would apply our treatments. Okay, so the first treatment was the online prep course. And the second one was the traditional classroom prep course. Okay, from there, we can compare the ACT results. Okay, now we're just going to repeat this process for the juniors. We're still going to do random assignment. What's going to look different is just the numbers in after we split up our block. So we still have group 1 and group 2. Okay, but we're splitting 30, so this one will have 15-ish, and then the bottom one will have 15 as well. Same treatments apply, online prep course and the classroom prep course. And then within those two different groups, we're going to compare the ACT scores. Here's the last step, because right now we've only compared how online and classroom works within a class. We're going to take those two classes and put them together at the very end and combine the results and compare them one more time. Okay, this design is called random block. And I want to really emphasize these are our blocks. And they are not the same thing as strata. Okay, it seems like we're stratifying into two different groups because it's intentional, but the big difference between strata and blocks are when the separation is happening. So here, these 50 students were chosen already for the sample. When we do stratified, it's a method of sampling here. We didn't choose these 20 seniors from a bunch of seniors after the fact. We chose these 20 seniors because they were chosen in our original sample. Okay, so strata happens, like stratified random sampling happens to choose the original sample. Okay, blocks are done in an experiment, different variables that we're trying to control for. Okay. Number 3 asks a slightly different question, but I want you to try this one, and then we'll talk about it together. Go ahead and pause the video and attempt this one. Okay, this one's not quite the same as what we just did. We're still trying to control a variable, GPA, but we won't be able to do it in the same way because it says we're just going to look at the juniors. Okay, so we're not blocking it by two different classes anymore. Instead, we're thinking about GPA. And GPA for blocking doesn't necessarily work because there's not really a cutoff of where you could put it. Like suppose you wanted 2.0 GPA or higher and then those below a 2.0, we can't really guarantee how many students we would have in each of those groups. So instead, there's this design called matched pairs. And how this works is you're going to take your 30 juniors, and you could do this for the seniors as well, but it just asks about the juniors, and you'll put them in order from highest to lowest GPA, or vice versa. Okay, but what you're going to do is take the two students with the highest GPA and pair them. And what you're going to do is flip a coin to assign one to the online class and one to the teacher class. That ensures there's the high GPA in both groups. And then you're going to repeat this process with the next two highest, and then so on until you get to the bottom. Okay, until all of the 15 pairs of students are assigned. Okay? They chose flipping a coin as a random way to assign. We could have also used a random number generator to choose them and assign them that way. The reason we did flip a coin, it is a random way to decide when there are only two options. We only had two options, the online class and the teacher class. Okay? So matched pairs is when you are ordering them and taking top two, next top two, and so on to make sure that those things like GPA or anything numerically based aren't affecting the results of your experiment. Okay, so let's do some vocab here. It says, in an experiment, a blank is used to provide a baseline for comparing the effects of treatments. Our baseline is called our control. Okay. Sometimes, depending on the purpose, the control group is an inactive treatment, and sometimes not necessarily. It says there's another option. It could be, if it's an inactive treatment, it's a placebo. An active treatment, something we applied, or no treatment at all. Okay, no treatment at all is something that we've seen often here with our ACT prep class example, the first one where we didn't have the one group go to any ACT prep course. Placebo effect, we already talked about that some subjects in an experiment will respond favorably to any treatment, even in an active one, just because of mindset. Okay. In a something experiment, neither the subjects nor those who interact with them and measure the response variable know which treatment a subject responds. So this is a type of blinding where neither the subjects, okay, or those people who are collecting the data know about the treatments. That's called a double blinding. Double blind experiment. Okay, but we could also have where either the subjects don't know or the people who interact with them don't know, and that's a single blind. So we talked about this with the caffeine example. Okay, caffeine we could blind from both groups. Okay, we could show, we could have the caffeine label covered and then let either the people who are drinking the caffeinated soda or the non-caffeinated soda, let them not know the difference, and the people who are measuring the results not know who was in each group. Okay, that would be double blinding. When we're talking about the ACT online versus in person, okay, they're going to know if they're online or in person, the subjects will, but we could blind the results from those who are interpreting it, so that could be a single blind study. Okay. So we've talked about some of these things already. We're just going to add names to them. The principles for designing experiments look like this. Okay, so comparison, we have to compare two or more treatments. We have to split them up into groups somehow. Okay, we talked about observational studies where that necessarily wasn't happening. They weren't randomly assigned, and that's our next one here. So we couldn't compare. We didn't have baseline data to do that. Random assignment, okay, we want to make sure it's chance. Usually a random number generator is our best bet there. But it decides who goes to what treatment. Okay, this does a couple things for us. It helps us get roughly equivalent groups. Okay, so that's one thing. And it also, because of those roughly equivalent groups, is going to balance the effect of other variables. Okay, even without blocking for other variables, random assignment is going to help us take out some of the bias, because if we're randomly assigning them to groups, then there's just as likely, hopefully, if I go back to this before we were blocking, let's talk about the juniors and the seniors real quick. Before I decided to block it this way, if I was just randomly assigning the 50 students to the two different groups, by random choice, we hope that there would be a decent balance of juniors and seniors in each group. It's not guaranteed, and that's where the blocking kind of helps, but with the random number generator, we do kind of control for that. And then that control, it says, keeps other variables the same for all groups, especially variables that are likely to affect the response. Okay, we're doing this to avoid confounding variables, and it also reduces the variability in responses. Okay, so it's not if we're controlling for the group, then we're not going to see as wild or differentiated answers when we go to compare our results. Replication, it's not exactly the same thing as what it means in English. Okay, replication here, it means we're just using enough subjects so that any differences in the effective treatment can be distinguished from chance occurrences. Okay, we are using a big enough sample. That's all it's saying. Okay, replication doesn't mean if we repeat this process, it'll happen the same way. Instead, we are saying that we used enough subjects to start with that we can ensure that the differences are taken care of by the building of that experiment versus it just randomly happened that way. Okay, so replication is making sure our sample size is large enough. Okay, so you are going to check your understanding, meaning you're going to complete the rest of this worksheet. So it's A through D on this side, and then the back side I spread out real big so you have plenty of room to draw your little charts. But you're going to try those ones and then come back to the video and I'll explain how they look. Okay, so the first one, we want to have a baseline. So something about a control group is why we wanted to make sure that there was one that didn't have any markings at all. Okay, so that was before the treatment was applied, the no treatment in this case. Then it says, suppose they had 1,200 cows, how you would use a random, or how you would use, how you would randomly assign the cows to treatments. And we're going to use a random number generator almost always. Okay, so we're going to label the cows 1 to 1,200. That should be always your step 1. Whatever you're talking about, you're labeling them 1 to whatever. And then we use the random number generator to select, we did 400 because we had 3 different groups this time. 1,200 divided by 3, 400. Okay, so you're going to assign those corresponding cows. So take the numbers that you get, and those are the cows that get the eyes. And you could have started with a different group. It wouldn't have had to be the eyes first. Then you're going to repeat that process to select 400 more, and those ones are going to get the crosses. And then the remaining ones get no marks. Remember, the order of these 3 items does not matter to me. What does matter is you have this item, and you know that you're selecting 400 unique numbers each time. Okay, we want the groups to be roughly equivalent. Okay, the purpose of random assignment is to control for other factors that may be confounding the situation. Okay, so it could be cow size, it could be location, if maybe some cows are in a location that is more safe or more dangerous for predators. Okay, things like that we're trying to control for by randomizing. Okay, here's how your outline should have looked roughly. Okay, we have 1,200 cows that are randomly assigned. Group 1, Group 2, Group 3. Treatment 1, Treatment 2, and Treatment 3. Again, I don't care what order you put those in. That doesn't matter. But what we're doing is comparing the number of deaths to see if the treatment is causing the improvement in our not having as many people die. Okay. Right, the next one was talking about a political strategist designing an experiment to compare the effectiveness of 3 different YouTube advertisements. So completely random again, you're splitting them into 3 groups because there were 3 ads, and then you're going to compare the effectiveness because that's what it was asking for on this one. Okay. The next one was more complicated because randomized block, we have to split up into each of them. Okay, so for this one, we split them up by age. Okay, that might be appropriate when we're talking about YouTube advertisements. Okay, older generation may react differently than younger. Okay, you may have chosen another block. You were just supposed to justify why you chose the split that you did. Okay, no matter what you have here, your next section should look roughly the same. Random assignment, going to the 3 groups, compare them, and make sure your last step at the end of these random block designs has combine and compare. Okay, in this case, the block design helps control age as a confounding variable. Again, you may have found or thought about something that wasn't age. That might also be confusing the causation here. Okay, but the important part to know is we're learning about blocking here, and there's going to be, with blocking, lower variability of the results. Okay, that is the benefit. And that lets us hopefully determine which ad was the most effective overall despite age or whatever else you chose. Okay. Your homework is on sapling again. Please, please come see me if you have any questions. There was a lot of content today, so I want to help if you get stuck.